Hi, my name's Hannah Longfellow. I go to Oakton High School, and my experiment is the effect of mask type on filtration quality. Almost 1 million people have died of COVID in the United States. COVID is spread by respiratory particles emitted from someone's nose or mouth when they talk or sneeze. Although the actual virus is very small, the respiratory particles containing the virus are 5 microns in size or less. These particles can stay in the air for several hours and can eventually make their way into the airways of others, transferring the virus. Masks block these particles from being emitted from infected people and also block the particles from entering another person's airway, helping to prevent the spread of the virus. This experiment tests the effectiveness of different mask types at blocking particles. The independent variable is the type of mask being tested. The dependent variable is the measurement of particle density in the air after passing through a mask attached to a mannequin head. The experiment measures the density of 1 micron particles passing through the mask in micrograms per cubic meter. As a control, the experiment measures the particle density in the mannequin head with no mask. Constants include mannequin head, sensor, placement of sensor, diffuser setting, fan setting, particle density of surrounding air at the time of measurement. This is a simplified description of the setup steps for this experiment as illustrated on the next slide. The entire experimental apparatus is enclosed in a large plastic enclosure to create a controlled environment for the air particles. This enclosure is illustrated by the blue outline. The experiment uses 2 air particle sensors connected to Arduinos, which are attached to LCD displays showing the density of 1 micron particles in micrograms per cubic meter. One of the sensors, the background particle sensor, is used to measure the background density of particles floating throughout the air in the plastic enclosure. A diffuser is used to generate a high level of background fine water vapor particles. A tube runs from the mouth of the mannequin head to an isolation box with a second particle sensor inside. Air is drawn into the mannequin head through the tested mask using a fan placed at the end of the box. Air is pulled through the mask, which filters the particles, so filtered air is pulled into the isolation box to be measured using the second sensor. This measurement of filtered air is made when the background particle density generated by the diffuser is 500 micrograms per cubic centimeter. These are photos of setting up the experiment and gathering data. The top left photos show assembling the Arduino's particle meters, LCD displays, and loading the software onto the Arduinos. The top right photo shows the measurements taken during the N95 mask trial from the 2 Arduino meters. The bottom left photo shows the arrangement of the mannequin head, diffuser, background particle sensor, tube running through the mannequin head, and brown isolation box. The fan is inside the isolation box and cannot be seen. The bottom right photo shows trials of the surgical mask, KN95, bandana, and control with no mask. This graph shows the experimental results. The measurement shown is the density of the air filtered by each tested mask and the no mask control. The filtered air particle density is measured for 1 micron particles in micrograms per cubic meter. The lower the particle density of the filtered air, the more effective the mask is at filtering 1 micron particles. The effectiveness of the masks is shown in order from least to most effective. As shown, each mask filtered some particles. The bandana was not very effective, having almost the same amount of particles passed through as no mask at all. The KN95 and N95 masks were most effective, filtering a large number of particles. This data table displays the average, standard deviation, and range of particle density measures for all trials of each mask type as shown in the previous chart. The large standard deviation is caused by differences in the mask's seals, as the mask was removed and reseated for each trial taken for the mask. This is realistic as each time a mask is worn slightly differently and fit varies from person to person. Looking at the results, all masks provided some filtering, but the results varied quite a bit. Multiple trials of the same mask were only somewhat consistent with fairly large standard deviations. As stated earlier, these deviations likely represent realistic differences in how well masks were sealed to the mannequin head between trials, similar to differences in real-life mask wearers. N95 and KN95 masks had similar particle filtration properties, with N95 being 6.5% more effective than KN95. In comparison to the bandana, the N95 mask was 23 times more effective, which is a very significant difference, and the KN95 mask was 19.9 times more effective. The fake KN95, which had no certification, was 17 times more effective than the bandana, and the surgical mask was 12.6 times more effective. Finally, the cloth mask was 3.8 times more effective. One possible source of error is some particles may have leaked through the seal connecting the tube and box, which would increase readings. This could be improved by using a suction seal. Another improvement would be to take automatic control of the background particle density so that measurements would be taken with a more consistent background. This experiment was done to inform people of the effectiveness of different mask types. The hypothesis was correct, with the N95 mask providing the best filtering and having the lowest particle density passing through the mask. The KN95 mask is also an effective option if sealed properly. The fake KN95 mask was more effective than expected, being almost as effective as a certified KN95. But not all fake KN95 masks will be as effective since they aren't all made equally and may be poor quality. According to the CDC, 60% of KN95 masks are fake, and it's hard to know where they came from. The only way to be sure of quality is to get a mask with certification from an authority like NIOSH or the FDA. The effectiveness of mask types vary greatly. Bandanas provide very little protection. For greatest protection, N95 or KN95 masks should be used. Thanks.